So when you read this question, you'll realize that this was the same as the question that we did in part 1, except it's asking you to resolve the forces to determine the third force. Now, resolving forces means that we break it down into its I and j components, and then we solve the I and j components separately. So I'm going to do this one quite quickly because we've already looked at a lot of the language. So we're making our force diagram. One force is going 5 newtons horizontal, one is going at a right angle to that, 6 newtons, and then we're trying to find this third force here. Now, we're resolving the forces, so that means we know that it's still going to be the same. F3 plus F2 plus F1 is going to equal 0. But now when we're breaking it down into its I and j components, I'm going to do very similar things. So F2 is still going to be 6j, F1 is still going to be 5i, and I'm going to substitute this formula in as my third force. So it's just going to look like this. F3 cos theta I plus F3 sine theta j plus 5i plus 6j. Now, this is where it's slightly different. I'm going to grab this component with the I and this component with the I, and I'm going to go over here and solve that component. Well, that should be an I. Okay, so now I'm going to take this to the other side, and I'm going to start ignoring the I's because I'm only working in I components here. So 5 is equal to F3 cos theta. Now we're going to come back to that because we're going to go over here and do our j component, and then we're going to be able to solve simultaneously. So in this section here, now I've got 0 equals F3 sine theta plus 6. Take the 6 to the other side. So now I've got negative 6 is equal to F3 sine theta. Now, you can see I've got two variables. Anytime you see two variables, you should be thinking that you're going to start solving things simultaneously. So I'm going to grab this cos component here, and I'm going to move this underneath so that I'm left with F3 is equal to 5 divided by cos theta. Now, I'm going to substitute F3 in over here, 5 over cos theta. Fill the rest of the equation in around it. Now, from this point, all I did was chuck it in the calculator using solve n. And then because it's a cos function, it'll go through with like multiple solutions. So you just go to the one closest to 0. So this will give you that theta is equal to 50.19. And that's going to be the angle that it makes with the x-axis. This is why it's good to always think about it in terms of the angle it makes with the x-axis. Now that I've got that angle, I'm going to throw it back in here to find out what my magnitude is. So F3 equals 5 divided by cos of 50.19 degrees. And that's going to give me that F3 is equal to 7.8. And now that I've got that, I'm happy. It might have given you a negative here, which doesn't really matter. It's just whether or not the force is going positively or negatively. It's still the same force. Okay, so I still, even though I'm solving using a different method, I still need to put it back in terms of where it is in relation to one of these other axes. So I'd still do 180 minus this gives me that this force, so F3 has a force of 7.8 newtons acting at an angle of 180 minus 50 gives me 130 degrees in the clockwise direction to the horizontal force.